Okay, so today we're just going to do a simple Fourier series problem. First, compute the coefficients of this. So basically something that I like to use to remember this formula is that no hats are allowed in class. So that's why you have a negative sign in front of the negative I and x. Whereas when you have the f of x formula, that's just going to be the positive. So this is going to be positive. Okay, so let's do this. When we are computing the coefficients, we are going to want to use integration by parts. So x e to the negative minus x, this is 1 dx, e to the negative I n x dx, e to the negative I n x over n, add this, subtract this. So our formula is going to be 1 over 2 pi from x negative e x over I n negative pi to pi plus the integral negative pi to pi of e to the negative I n x over I n dx. Okay, and notice that when we calculate this, this is just going to cancel because we have e to the negative pi I n, so just draw a unit circle, is here. And then e to the negative, e to the pi n, where n is an integer, is also going to be here because pi and then negative pi give you the same thing. So this is just going to cancel, and there's no x in the denominator. Okay, and then for this term, we have, just be careful with the negative signs. We have negative pi e to the negative pi ni over I n minus negative pi e to the pi ni over I n. Notice that this will just become a positive. So this turns out to be 2 pi times negative, and again, these two terms are equal, so we just have negative 2 pi times negative 2 pi e to the pi ni over I n. And these will cancel. So we get negative e to the pi ni over I n. Now the question is, can we simplify this more? And the answer actually is kind of. Like, I don't know if this counts as simplifying, but notice that when n is even, we will have this point, right? This is going to be our e to the pi ni. So this is n is even. When n is odd, so 1, 3, 5, 7, our e to the pi ni will be here. And what does this mean? Well, when we expand this, remember that negative e to the pi ni over I n is just negative cosine pi n plus I sine pi n over I n. And here notice that our sine term will always be 0, so we don't have to worry about this. And our cosine term will be negative if n is odd and positive if n is even, which means that we actually can write this as a piecewise. So we can have negative e to the pi ni over I n equals, let's have a piecewise. Piecewise, so it's negative if n is odd, if n is even. that means that it's 1 over in, n is odd, and negative 1 over in if n is even. Now notice that when it's 0, we kind of have a problem, right? Because you can't divide by 0. But we can actually go back to our original expression. So notice that when n is 0, this will just cancel, which means that for n equals 0, we have f of 0 equals 1 over 2 pi from negative pi to pi of f of x dx. And then when x is 0, that's just going to give us, when n is 0, this is just going to give us 1 over 2 pi, negative pi to pi of x dx, x squared over 2. So this turns into 0 because x squared and negative x squared are the same. So f of 0 equals 0 when n equals 0, and is not equal to 0, we have this. So now we have computed the Fourier coefficients for all n and z. Part B will be in the next video.